Hey guys, welcome to 1.2. Today we're going to talk about function notation. Students will be able to evaluate and perform operations with functions. So, when you evaluate a function, all you're doing is plugging in specific input. Remember, input are my x value. First example, it says, given the function f of x equals 5x minus 2, I want to evaluate each of these. For f of 3, remember, wherever I see x, I'm going to replace it with 3. 5 times 3 is 15 minus 2 is 13, and that's it. F of 3 is equal to 13. What about f of negative 2? Same goes. Using my f function, I'm going to replace x with negative 2. 5 times negative 2 is a negative 10, minus 2 is negative 12. Remember, if you're not sure, check it in the calculator. The negatives is what you guys get caught up with. So, g of x is equal to g squared plus 4. I want to find g of 3. I see x, I'm going to replace it with 3. 3 squared is 9 plus 4 is 13. Find g of 0. Wherever I see x in my g function, I'm going to replace it with 0. This becomes 0 squared plus 4. 0 squared is 0 plus 4 is 4. Excellent. Now I'm giving h of x is equal to the x power. So I'm using my h function and I want to find h of 3. So this becomes 2 to the third power, which is 2 times 2 times 2. 2 2's 4, 4 2's 8. Perfect. The second one says h of negative 2. So this becomes 2 of negative 2. Now a lot of you, this is not familiar when you have a negative exponent. So please put it in your calculator. 2 to the negative 2 power, it should gives you a quarter. Okay? This is a rule of exponents, which we're going to talk about later on. So, function notation. This is basically, you always see y is equal to f of x, some kind of output, and this is my rule. My x is what I'm going to be inputting. Function rule comes in 3 forms: equations, graphs, and tables. Let's look at an example with a table. Boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit and begins to cool. The temperature readings are taken each hour and are given in a table below. In this scenario, the temperature T is a function of the number of hours. Evaluate T of 2 and T of 6. T of 2. So I know T represents the temperature, and I want to find T of 6. So first thing, when the hour is 2, that's my input. What's the temperature? It's 104. What about T of, let's write that right here, T of 6. When the hour is 6, my temperature is 68. Now, B is a little trickier. It says, for what value of H is T of H equals 76? So my output is 76. How many hours does it have to be in that room before it gets to 76? So this is my output, my T of H. When is this equal to 76? So I go over, bam, I see it right here. What is my H for? So T of 4 is equal to 76. So in this case, for B, H has to be equal to 4. Perfect. C, it's a little bit more application. Between what 2 consecutive hours is T of H equals to 100? So between what 2 consecutive hours is T of H equals to 100? So I go down, T of H, where is it equal to 100? So I know it has to be between here, 100 is between 85 and 104. So between what two consecutive h? So it has to be, look up, corresponding hour, so it has to be between 2 and 3 hours. So as somewhere between 2 and 3, my outcome, my output will be 100. Moving along, now this is an example with the graph. So the function y equals f of x is defined by the graph shown below. Answer the following question based on this graph. Evaluate f of -1. Go to my graph, I look for -1. Remember, what's in your parentheses is your input, which is your x values. This is my x-axis. Right here is my -1, but it actually crosses at that point, so f of -1 is 0. It also says evaluate f of 1. So my graph, this is 1, I go up, this is a point right here, and I want to get the y value, my output, so 1, 2, 3, 4. F of 1 is 4. And the last one it says is f of 5. This is my input, so I need to find 1, 2, 3, 4, 5. I know it's right here, but I need to see where it goes down. 1, 2, 3, 4. And because I'm going down, so f of 5 is going to be -4. Evaluate f of 0. What special feature on a graph does f of 0 always correspond to? So f of 0, this is my 0. F of 0 is this point right here in red, which is 1, 2, 3. So f of 0 is equal to +3. What special feature? What do you notice about this f of 0? This is always where the graph intersect, intersect. The intersect the y-axis. So f of 0 is always going to be where this graph intersect the y-axis. C says, what value of x? Solve the equation f of x equals 0. What special features on this graph does this set of x values that solve f of x equals 0 correspond to? Now, I know that my y value is going to be 0. Remember, that's my output. So I know that my y value is going to be 0. So let's clear the graph here. My y value is 0 is anywhere here. So I see 1 point, 2 point, 3 point. Okay, that's when my graph is equal to 0, because remember, this is 0, my origin. So what are these points? What are these coordinates? So when x is equal to -1, it's 0. 1, 2, 3. When x is equal to 3, it's 0. And then the last one, say 1, 3, 4, 5, 6, 7. And when x is 7, my outcome, my output is 0. And what's special feature about this? Notice where these dots are. This is actually where the graph, these points are where the graph intersect the x-axis. So when f of 0, I'm trying to find the outcome, that's the y-intercept, and when I'm trying to solve what value of x makes it equal to 0, that's your x-intercept. Part D says, between what two consecutive integer does the largest solution to f of x equals 3 lies? So when is this equals to 3? So what I'm going to do is just draw a line so we can see this. I'm going to draw a dotted line at when the outcome, when the y value is going to be 3. So 1, 2, 3. And there is my line. That's when the outcome is going to always be 3. So I want to find between what two consecutive integer does the largest solution. So the largest solution is always the one farthest to the right, which is right here. So between what two numbers? So it's going to be between this number right here and this here. So let's see what that is. This is 0, 1, 2, 3, 4, 5, 6, 7, and 8. So the largest is going to be between 7 and 8. Exercise number 4. For the function y is equal to g of x, it is known that g of negative 2 is equal to 7. Which of the following points must lie on the graph? So I know I have some function g of x, and I know that g of negative 2 is equal to 7. So remember from earlier we said this is going to be my input, and my 7 is my output. My input is also known as my x, and that's my y. So if I was to write this in a coordinate pair, it would be negative 2, comma 7, choice number 2. Number 5. Physics students drop a ball from the top of a 500-foot high building and model its height as a function of time with the equation h of t is equal to 50 minus 16t squared. Using tables on your calculator, determine to the nearest tenth of a second when the ball hits the ground. Hint, the ball hits the ground when h of t is equal to 0. So h of t equals to 0, we know it's going to be when 0, h of t is 50 minus 16t squared. So I want to find out what's the value of t. When is this going to be equal to 0? So t is going to be equal to what? So what I want you to do is pause the video, make sure you get a calculator, and I will wait for you. Yes, go get a calculator now. Thank you. So now that you get your calculator, turn this on to the home screen, which looks like this. And I'm going to go to graph. You should see something that looks like this. If you don't see this, remember, hit tab. And I'm going to enter my function, which was 50 minus 16. And I'm not going to use t because this calculator doesn't recognize t, but we're going to use x squared. 50 minus 16x squared. Hit enter, you will see a graph like this. So what I'm looking for is when this graph, what's this point right here, when it hits 0. So you go to menu, go to trace, and I want to graph trace. What that is, you just hit this arrow because I want to go down, and I want to go all the way down here. See, it says 0. This is my x value, and this is what I'm looking for. So again, I went to menu, trace, graph trace, and I'm using this up and down arrow to find when it hits 0. So when it hits 0, it's at 1.77. So my t is 1.77, but the question says rounded to the nearest tenth. That means 1 decimal place. So t is going to be equal to 1.8 second. Now moving along, we're going to talk about operations with functions. They're four basic operations: adding, subtracting, multiplying, and dividing. So the first one we're going to talk about is adding. I want to add f plus g of x. So this is the same thing as me saying f of x plus g of x. F of x, and I like to keep it in parentheses, is 3x minus 4 plus g of x is x squared minus 4x plus 7. I like to keep it in parentheses so that I know and double check what I need to distribute versus what I don't. So I'm going to rewrite this now. This becomes 3x minus 4 plus x squared minus 4x plus 7. Combining my like terms, I see there's only one x squared, so this becomes x squared. 3x and minus 4x are like terms. 3x minus 4x will give me minus x. Then I'm left with minus 4 plus 7 is a positive 3. And my final answer will be x squared minus x plus 3. Subtracting, on the other hand, is, say, f minus g of x. You can see this either way for the regions as the same thing as f of x minus g of x. And the order does matter, okay? So, f of x again is 3x minus 4. Take away, and I keep everything in parentheses, x squared minus 4x plus 7. Now I'm going to rewrite this without my parentheses. This becomes 3x minus 4. Because this is negative, remember that invisible one that's right here? I'm going to have to distribute that. So this becomes minus x squared plus 4x minus 7. See why I keep it in parentheses? Because when I distribute that over, it changes. So again, minus x squared. 3x plus 4x is positive 7x. Minus 4 minus 7 is minus 11. So f of x minus g of x is actually minus x squared plus 7x minus 11. Multiplying will be written as f of g of x. So f of g of x is 3x minus 4 times x squared minus 4x plus 7. So we're going to go ahead and do my box method here. Remember, this time I'm going to need a 3 by 2 because I have 3 terms in one and then I have 2 in another. So this becomes 3x. It doesn't matter if 3 is on this side or that side. And this is minus 4. I have x squared minus 4x, and this is a 7. So this becomes 3x cubed, 12x minus 12, a negative times a positive. 7 3s 21x. Let's multiply this, becomes negative 4x squared. 4 times 4, negative times a negative is a positive 16x. 7 times negative 4 is negative 28. Now that I did this, I'm going to combine by like terms. I see the x squared common and the x's. When I combine that, I'm going to get 3x to the third. What is minus 12x squared minus 4x squared? That will give me minus 16x squared. 21 plus 16, that is 37x, and then minus 28 at the end. That's by itself. So when I multiply these two functions, I ended up with 3x to the third minus 16x squared plus 37x minus 28. Dividing is pretty simple. F of x divided by g of x. What's my f of x? My f of x is 3x minus 4 over my g of x, which is x squared minus 4x plus 7. And I just leave it as this. And that's my final answer. Alrighty guys, work on your questions.